Okay, so like I was talking about last week, we're going to do some DNA, RNA, and protein synthesis learning. I kind of already got the kickoff for you guys. So the double helix was discovered by Watson and Crick, and they discovered it resembled a spiral staircase. So like that representation I had last week, where it was the spiral all the way down. It was by Watson and Crick. Yes, yes. What's this? So we're past this, right?
We're not DNA structure discovery.
This part's not in our packet. It says double helix, but it's not the right whole.
Oh, okay.
Our DNA structure.
DNA structure?
Discovery.
Are you serious? It's all over the internet. Mr. Wagner, can I look at my sweatshirt my locker?
Quickly. I don't know. That's a good question.
Preston, I'm going to restart.
Well, so it's not. Why? May I see it? Thank you. DNA structure, nucleotides, blah, blah, blah. Discovery, X-ray. Okay.
I'm going to play Cookie Clicker and beat you in that too.
So what we're going to do,
It's on the same app.
we need, okay, I'm just going to get to a point where you can do the activity that we're doing tomorrow, if that works. So we're going to do a little bit of learning on this. It won't necessarily be on your papers. Just listen, pay attention. DNA nucleotides. So those are, like I was saying, it's a nucleic acid made of two long chains repeating units called nucleotides. That's where you get the A, G, C, T, and U. Those are nucleotides. It is these nucleotides that are a 5-carbon sugar, a phosphate group, and a nitrogenous base. DNA nucleotides. So this is the base that accepts the hydrogen bonds. Is it fine if I have this down like this? So
Yeah, that's fine.
yeah, everybody can see that?
Yeah,
Okay.
I understand.
So basically what this is saying is when we have the A and it bonds with, what does it bond with? Do you remember?
Bond holds DNA together.
A and T, yep, and a U, possibly. So let's just think about DNA right now. So it bonds right here, right? This bond is going to be called what we call a hydrogen bond. And the thing about a hydrogen bond is it's actually pretty weak, but you're going to have a sequence of, let's go C, T, A. So you're going to have C, G, A, T. So you're going to have a whole bunch of these. I forget how many. I want to say like 1 billion of these in one DNA. And so they're super weak. So they'll break and then come back together. Just kind of like it's gonna be kind of like fluid almost, where they're breaking and coming back together. They're weak, but together they're strong. That makes sense.
Teamwork makes the dream work.
That's right. Teamwork makes the dream work. So that's the main thing about the hydrogen bonds that I know. The bonds hold the DNA together. So we did it 2 ways. We did the circle way, where you draw it like this, and then you have the, a.
So basically, in Fortnite terms, it's like if you only have one wall, it's not that strong. But if you have a lot of walls, then you could build you could crank 90.
Pretty close, yeah, yeah. So basically, the hydrogen bond, in Fortnite terms, the hydrogen bond is a wood wall. But you need a lot of wood walls to stop a bad guy. That's stupid. That wasn't a great representation. Yeah, you do need the full metal ones, but then that's like replacing the bond itself. It doesn't really work in Fortnite terms. But anyway.
Can you do Minecraft terms after Minecraft?
I could try that.
No, you don't.
No, you don't. I only know this.
Okay.
When you put up a dirt wall instead of a bedrock.
So these are the bonds that hold the DNA together. So one strand of DNA looks like this, and the other strand looks like this. And together, the hydrogen bonds hold those 2 strands together. If that makes sense. Okay. Hydrogen bonds are what hold, same thing. It is these bases that face towards the center. So like I was saying, the A, T, G, C, C, G. They're going to be facing towards each other. What's up?
Okay. So
Yes.
Is there like something on the end? Like, is it like a little bar with a little? Like,
I know what you. Okay. Yep. So okay. Repeat that. I'm sorry.
what's it? Like, obviously, there's not just like letters in my head.
Yeah, absolutely. Okay, this is going to be very loose representation, but it'll get the. So this is DNA, right? So you have a phosphate group. So phosphate. And then you'll have a sugar right here. It's a 6-ring sugar, so it's going to go look kind of like, that's supposed to be a hexagon, kind of like this. And you're going to have another nitrogenous base. So that's going to be right here. So this is where you'll have the A. This is like adenine. I'm making stuff up. We'll call this adenine. And then so basically, you'll have the same thing, and then there'll be another DNA molecule down here. That makes sense. There, that's supposed to be sugar. Sugar, that's all right, we'll get there. Sugar, okay, these are 2 sugars, right? And then they'll be like this. It's a big long chain. And then over here, instead of this, here I'm going to change this up just a little bit. Instead of this, we're going to have this like that. Let's say it looks like that. And then over here, we're going to have the same phosphate group, phosphate. And then we're going to have our 6-ring sugar, same thing. So these are 2 different DNA strands. Then we're going to have another one. And then boom, sugar. Oops. Sugar. Sugar. So these are both sugar. And then what does A pair up with? What is A? Adenine.
Oh, T.
T. Yep. So on this sugar, it's going to be, let's say it looks like this, this, and then this is T. So the A is going to bond with the T. And here, this is above your head. But the reason A and T bond together is because this has, there's purines and pyrimidines. I can't remember which one's which. But this one has 1 hydrogen bond. And if I were, this is going to be, I'm just going to do circles to make it easier. If this was C and this is G, it's going to be 2 hydrogen bonds. But don't worry about that. It's going to have 2 hydrogens that line up instead of just the 1.
You just made it fun by having hydrogen.
What's that?
It's more fun when you have hydrogen bonds because then actually.
Oh, okay, good. So this is DNA strand B, or A, it doesn't matter, and then DNA A. So it doesn't matter which side's which, but this is 2 strands of.
This is that just zoomed in.
Yes, yeah, basically. So this is.
So basically, Fortnite terms.
It's this much. We're seeing that much of it. Oh well, since we have 2, we see that much.
So in Fortnite terms,
If that makes sense.
When you're like aiming with the regular AR and then you use a scope AR and that's what you see.
Yeah.
Sure. Yeah. So this is just zoomed in. This is the zoomed in portion of this. Okay? And so each of these, so every one of these lines is this right here. It's just a simplified version of that. So this line right here is the same as
What do you say?
this.
Carson, are you joking me? Ah!
All right. So adenine. So when I say A, it's adenine. T is thymine. C is cytosine. G is guanine. And U is uracil. Okay? What are those? They're nitrogen, no. They're nucleotides. So this is an adenine. And it's just a bunch of chemical, I forget. I can look it up in a little bit, what exactly the structure is. But it's basically a nucleic acid. That binds, yeah, see, it doesn't make sense, right?
What's it called?
You know, I want it to make sense.
I know, yeah, that's fine. It's just like 4 steps above.
You look like you belong in.
Took too long, doesn't work.
Like a
Let's do.
Southern American gang.
Oh man.
Like a Brazilian mob.
Okay.
Italian mafia.
That's pretty good. All right. We're gonna do this slide and this slide. So That's all right. We don't have these. We do not have these. We're doing off the cuff here, so just hold on. You can draw these down. I really recommend it. That's why we have the science channel. Is that, isn't it? I only have so much room, and I'm a drawer. That's how I explain things. I'm terrible at explaining things in words. The movie or the TV show? The show. All right. How replication occurs. So this process occurs during, before mitosis. So this process occurs before mitosis. As a template, will allow for 2 new strands that are identical. After replication, that identical strand separate and form a new cells in cell division. So, can somebody explain to me in their own words what this means?
Does that mean Fortnite
Replication occurs before mitosis.
Yes, replication occurs before mitosis.
So it's like
Okay.
It's like when you and your squad are all loading up, but you all pick the same skin.
No, it's like when your health is low and you have no shield, means you can use a big pot and a small pot.
Give me Minecraft.
No and no, but we're going to stop with the Fortnite terms. They're missing the mark.
Fortnite terms really help.
So what is mitosis?
It's when the one thing splits into the two.
That's right.
One sec. Did you forget attendance?
Yes, I did.
Silly.
You did not ring twice.
Mr. McKinney's office. This is Mr. Wagner. Yes, I will. All right. Yep, bye. Anissa McGuire is supposed to take her. You're supposed to take your sister home right after school, is what I hear.
Right.
Okay, so where's my marker? There it is. Got it. What is mitosis?
I don't remember.
It's when a cell splits
Yeah, look.
and becomes 2, right? Guys, come on.
Longest yap session of my life.
Okay, so because it's not during mitosis, it's before mitosis. That's when replication occurs. So mitosis is when one cell splits and becomes 2 cells that are not identical but pretty close. But they're genetically identical. The DNA is identical.
Oh, so like in Fortnite terms, basically like way in the back when the rocket shot into the sky and it put a rift in the sky and eventually
No.
got so big that it broke in a whole bunch of them.
Not quite.
I think we're getting that.
As a template,
Basically, you said it splits.
No, it's like Loot Link, like getting split apart.
all right, no more Fortnite tonight.
Oh!
Fortnite. As a template will allow for these 2 new strands that are identical. So after replication, okay, so explain to me what this means.
I knew that.
What does this mean? This,
The process during before mitosis.
okay, so what is it trying to tell us right here?
The leading point to the cell division.
Okay, yes. So here, I'll explain it to you. So you have a cell with a bunch of strands of DNA, but let's say it's DNA, right? And during mitosis, what happens to the cell? We just talked about it splits and it makes 2 new cells. So that means that we're going to have 2 new cells. So we're going to have one cell right here. And so it still needs the same DNA. So it has to replicate and make 2 identical DNA strands. So these say the same exact thing. So it needs to make 1 strand into 2 strands, basically. It needs to double the DNA. What?
What if I mess it up and makes one that's the same and one that's different?
Cancer, the cell die. There's a million things. The cell, not a million, but there's a ton of things the cell can do to make sure that the DNA isn't messed up.
Wait, is it bad if the cell dies?
No.
Yes.
Yeah,
No.
it's good for it.
You want your cells to die
What?
because when cells,
Cells are evil.
if this DNA, let's say this DNA gets messed up in the process, and it starts in the message, or the part that gets messed up is the part that tells the cell to divide. It's going to keep on dividing, and eventually, when cells just keep on dividing without any like regulation, that's called cancer. So you want these cells to die. If it's broken, you want it to die or you get cancer. So,
if it doesn't die.
yep, and then if this cell can't, it'll do a thing called autolyse, which means the cell death, it'll kill itself. If this cell can't do it, then there's also other cells within your body, like white blood cells, that'll come and kill the cell.
What's a tumor again?
A tumor is a mass of cancer cells. So anyway, we needed to get this strand to make 2 identical strands, right? So that's where DNA replication happens. That's when DNA replication happens. So after replication, the identical strands separate and form new cells in cell division, what I just said. Steps in replication. DNA helicase is an enzyme that splits the hydrogen bonds.
So it splits the DNA.
It splits it in half, right? Absolutely. And the nucleotides are floating freely in the nucleus. Okay? And then I'm gonna show this to you in a drawing. They begin to assemble in the proper sequence from the template. DNA polymerase, remember this. I forgot to do it the other one. The helicase is also important. So DNA polymerase will cause hydrogen bonding to occur and seal the strand back into a double helix.
What did you just say?
I know, right? One sec. Well, we'll come back to this. I'm going to do it in a drawing, and you're going to be like, ah, makes sense.
Okay.
Flow of genetic information, RNA or ribonucleic acid, transcription. We're going to do this in a little bit. All right. So we're gonna replicate some DNA now.
We're gonna make some DNA.
Oh, do we get to make the candy?
Not yet. That's tomorrow.
Yes.
Yep, that is tomorrow. Okay. So we have DNA, right? It looks like this.
Yeah.
That's DNA, right? And we need to replicate it.
That is the worst DNA I've ever seen.
It doesn't actually look like that,
Say
believe it
sorry
or not.
now.
Anyway, so how we're going to represent this, it's going to look like this.
You think he's a jar now?
Okay, so this right here is our DNA strand. I just laid it down. I just took this, laid it down, and then I took the twists out of it. Okay, so this is the same thing as this. I just took the twist out of it and I laid it sideways. Does that make sense? So we're going to have A, G, T, C, G, T. And then we're going to have what here?
You'll have
C.
T, C, A, G, C, A.
No, I'm.
Absolutely.
A goes with T and G goes with C.
Yep.
That's all we need to know.
And
right?
so
GMC and AT&T.
that's right. So
I get to kick off.
GMC and AT&T, I kind of like that. That's not
Oh my
bad.
God, AT&T.
Yeah, AT&T. So A and T go together. GMC, G and C go together. I don't know if that helps anybody, but
That helps me.
sure. Okay, so these things are just the 2 strands, so it's just splitting right here. So we're going to also have T, G, C, T, A, G, C. And then what are we going to have if we have, what's the opposite side going to look like? A, C, G, A,
C, T,
A, oh, yep, T.
G, C, G.
Thank you, C, G. Okay. And so do you remember what the enzyme is that's going to split this in half? Not quite, not quite. So it's splitting the DNA. It's an enzyme. I talked about, I didn't underline it. I wish I would have. Nope. We're going to have, remember this, everybody? I would be drawing this down, by the way. We will need this. We're going to have helicase.
I swear I got it. I haven't.
We're going to have helicase, and that's going to be the thing that unzips our DNA. It breaks the hydrogen bonds.
What do you mean by that, Mr. Wagner?
It's like a coat, it unzips it.
Oh, okay.
Yep.
Okay, just the color.
So this is the unzipper. It breaks the hydrogen bonds. What's up?
What's the letter of the? It's a T.
T. It's a bad T. It's a T.
Don't even care Barrel. That's not cool.
Okay.
Mr. Wagner, you're probably one of the better Earth teachers I've ever had.
Thank you.
Why you say so?
Yes, I did. I'll get back to you on that. Okay, so we have the helicase. Is everybody tracking so far?
I'm almost done right now.
That's fine.
What is this?
I'll keep it up. Okay. So now we have a bunch of open-ended. We have a bunch of open-ended DNA,
What's
and we want to make 2 strands, right?
enzyme called?
Helicase. Helicase right here.
Hey guys, it's okay, he's exactly.
Yep. And then so we're also in the same area. We're going to have a bunch of. This is just floating, right? It's an A. So these are A. I don't know.
That's how I write mine.
You're going to hate how I write my P's. I go.
That's all I
That's how
read mine.
Russ
Oh, okay. All right. Never mind. Never mind.
That's how I read mine. What?
Okay. So back on task. We have a bunch of these nucleic acids floating around while this is going on. And so what will happen is they'll come floating around the nucleus, because this is in the nucleus, right? So they're just going to be floating in there. And so what's going to happen is through an enzyme, don't worry about which one, these are going to come and bind right here, right? So we're going to have a C go to the G, right? So these are all going to come here and attach to their own, right? Is this making sense?
That ain't no jet.
What?
So they will bond?
A 4? There's no 4. It's an A. It's a bad A. I'm sorry. Yep. So these are A, C, G, T. That's floating around there. And they're going to come bond to the 2 strands that we're making. Both of them. Yep. It's going to do both. So we're also going to come, let's go T. We're going to go right here. And then G is going to come right here. So they're going to all come and bond there. Okay? We're almost done. So I'm going to get rid of this. They're still there, but I'm getting rid of it to make room. And so is the helicase. The helicase is also there, but I'm getting rid of it so I can prove.
So, you want in mitosis, right?
This is during mitosis. Yep.
It is grabbing random ones,
Yes, and putting them with the corresponding.
putting them with the hormone.
Okay.
And then those will separate it.
So once we have this, now we have.
Oh, we're making, I think we're making the DNA things.
We are. So A and then T, G, C. Oh, wait.
Yeah, are you feeling okay?
Okay. I did mess up one thing. What did I mess up?
I know.
I followed it kind of good. We're good here. Oh, wait. I'm a genius. I did it right. That was not on purpose, by the way. These are going to be the exact opposite of these, right? Because it's the same DNA strand. It's just separated now. So that was completely by accident. I'm really proud of myself.
He's smart.
Yeah.
What's the one accident?
What? That T, A, G, C, G, or C, G, A, T. Those lined up. They weren't. I didn't mean them to, but I'm glad they did because that's what it's supposed to be. Okay.
I thought you were doing that earlier.
T, A, G, C. I was supposed to be. This is C. Okay.
You did it wrong. You failed it correctly.
So now we have these kind of bonded, but they're not really bonded because they still need. You know how I was talking about these sugars down here? There's sugars behind it. So these sugars need to be connected together. These are sugars, those little circles. And so we'll have our, what's the other enzyme that I underlined? Just talking about it. Starts with, what's that? Not quite. It's on the PowerPoint. It starts with a P. Starts with a P. Polymerase, DNA polymerase. Remember this one. Okay? So this will come in DNA. That's all right. Polymerase. So now we have the DNA polymerase, and basically this is just going to make sure they're all connecting and it's all good. And by the end, there's going to be sugars, right?
Energy.
Yeah. Yep. Well,
ATP.
it holds it together. It's a not quite. It's not an ATP thing. It's like they need sugars to hold it bond. It's a bonding molecule, not an energy in this particular example. Okay. And so by the end of this, we're going to have a brand new strand of DNA, right? Because it's going to keep on going and make its own strand. And are these the same exact DNA strands? Yes, they're the same exact thing. Now we just have two of the exact same thing. And now they can separate and go into the different cells from mitosis. Okay. Last thing, this is the, I needed to build up to it, but this is the key for today for the activity tomorrow. Okay. If you remember anything from today, I want you to remember this. So I'm just going to make A, C, G, T, E, O, oop, G, A, C, G, C, A. 3, 6, 9. Okay. So this is DNA, right?
What happens when your body has 0 ATPs in it?
You die. So these are each amino acids, right? Or not amino acids, nucleic acids, right?
Yeah.
It's like DNA. I just stripped it way down. Okay. And here, I'll do the. Okay, DNA. So why do we have DNA? What's that? It makes us different, right? So how does it make us different? What does it do? Do we? Yes, but how does it do it?
Like what we look like, our hair color.
Yep. Yeah, absolutely. I'll give you a hint. And by hint, I mean the answer. The DNA, what it does is it makes proteins in our body.
It codes your body.
It codes your body. It codes proteins specifically. And those proteins go out and they signal other stuff to start happening. But that's besides the point. DNA codes proteins. That's what you need to know.
I thought it took someone else, like an animal, DNA part to become an animal.
Yeah, you have to read it.
Okay, and so proteins are made up of amino acids. Remember that? Amino acids.
Yeah.
And an amino acid is coated with 3 nucleic acids. How many nucleic acids make one amino acid? And what's an amino acid?
I know.
Okay. No.
No, if you were paying attention, you literally just said it.
That's right.
You're a chess
Pay attention.
I think that's what they call it.
How many nucleic acids make an amino acid?
3!
What's an amino acid? What do amino acids make up?
They make a protein.
Proteins. Amino acids make up proteins.
I pay attention.
There you go.
Okay, there is. Where's it at? I gotta find it.
Are you recording this?
Yes, sir. All right. So on page, I should have had you get your book. Do you guys have these?
Yeah, I have that.
It's an amino acid
No.
table. Okay, that's fine. I will pull it up on the screen.
You go print them off right now.
No, because
I think you like men.
there we go. Okay.
How many rounds are in the NFL draft?
7? I don't know. Something like that. Okay. So, I have a strand of DNA, and I want to figure out what amino acids it makes, right? So, say I have, we're going to get rid of this. say I have a strand, we only need one side of the strand, A, U, G, T, oops, let's go A, T, G, C, good question. I will answer that in a minute. And we'll go G, C, T. Okay, so how many nucleic acids make up an amino acid?
23.
3.
2.
3.
26.
Right?
Impressive.
So let's make, do you remember the RNA? The difference between RNA and DNA?
I have it written down.
What's the,
It's half of the.
it's half of it, and it's what's the difference in between the codes? What's the letter? So
Oh yeah, there's a different letter.
there's a U, right? So this is DNA, and I want to make a strand of RNA.
You put U.
That's right. So it's going to be, where's the U go?
Right by the A.
There's no, yes, right by the A.
I'm blurred.
So this is DNA, and this is RNA. Okay? So U, and then I get what? T to what? A, C, A.
Wait, I thought here was a G. Oh.
I'm going to switch this one to A. C, C.
You.
Yep, U.
Dude, I
Hey.
was so confused there for a second. I thought you erased it on the computer.
Well, I'm glad you're back. Oh, no. Okay, so now we have our RNA. And so what our RNA does is it codes for those, it goes to the ribosomes, it takes this, and it goes to the ribosomes. I don't know why I drew that, didn't need it. This RNA goes to the ribosomes, and it matches with the amino acids, and it makes your proteins.
So that it can properly replicate.
No, so this is
Properly built.
about building proteins. Yep. And so it's going to take this message and build a protein with it. So again, one more time, how many nucleic acids in an amino acid? 3, right? So I'm going to go 1, 2, 3.
That was a little big.
1, 2, 3, and then it's going to just start again. 1, 2, 3, 1, 2, 3. And so we can actually figure out what amino acids code for each of these. So we're going to have UAC. Where can I find UAC? We're going to start with the first one. U, A.
S.
So we're going to get, you don't know it yet, TYR. We're going to call it TYR. And then we're going to have ACG. So A, C, THR. Thursday. It's like theramine, something like that. I'm not sure.
Thymine.
Not quite. That's probably, thymine is one though.
Ah.
I'm not sure. Anyway, CUA. Ugh. CUA.
It starts with I can't read it.
LEU. And so it's going to bring these amino acids to the ribosome. The ribosome is going to match it with its prospective amino acid. And then it's going to bond these amino acids together to make what? What did I just make there? What did I essentially just make?
A protein.
A protein. This is a protein.
Dude, I'm so good at this game. It's insane.
Protein.
Game called one.
You know, if we all thought of school as a game, maybe it'd be more fun. And maybe we would hate it.
Maybe I'd have to grade.
Okay, how did we do today? We covered a lot. Don't get me wrong.
Enjoyed it. Okay, so
A ton.
basically, cell division is
Pause it.
mitosis. It's supposed to cell in half.
There's
That
26
includes
amino acids.
that includes it splits the DNA with a enzyme called with something with an H.
That's right. That's right.
And then we also found out the creation
All right.
of
We will see you later.
amino